back to Explicit Physics Academic, and in our last class we were discussing on functions, and we talked on functions, and we discussed about mapping in a function, and we were able to solve few problems in functions, and at the end of the equations came in through our YouTube channel on the comment section, and people were demanding for more of the video. So we are coming in today to complete a section on functions so that we can proceed to other topics in calculus, that's the limit, the differentiation, the integration, and so on and so forth. So in this video we'll be discussing types of functions, problems in functions, that's function notation, and we'll end it at inverse functions. So that's what we're going to be stopping, and then maybe subsequently we will talk on what is graphing. When we discuss it in detail, then we'll now fall into graphing in functions. I believe that will make it more easier and more elaborative. Alright, let us dive in of what function is all about, or the types of functions. In type of functions, we are having the one-to-one function, we have the onto function, we have the subjective function, and then we have the minute-to-one function. There are four basic functions that we'll be discussing in this very class today. Let us look at the first one. We have the one-to-one function. A function is said to be one-to-one provided that to each value of the independent variable, they exist exactly one variable. And in the mapping of which we did in our last class, if you missed the last class, quickly go back to the channel and then look on functions. You will see functions part 1 where we discuss one functions. So in the one-to-one function, if you are given an equation and then you are asked, is this equation a one-to-one function? You should put in the value of the independent variable into the equation. Now when you put in those values and what you get exactly one value, then what your answer should be in that place should be yes, it's a one-to-one function. Why is it called a one-to-one function? From the word one-to-one, it means that for each value of the independent variable, there's exactly one value of the dependent variable. So that's why it's a one-to-one function. It does not need too much explanation. Just from the word one-to-one, you can be able to tell that it's a one-to-one function. That's why in this mapping of A, assuming this is A being the independent variable and B being the dependent variable, if you put in one value of this, you get exactly one of this, and this is the mapping. So I'm going to be giving one example on this one-to-one function and how to identify them in case a question is being asked. Let's proceed. To distinct element of the codomain. That is, a function is one-to-one if to each value of the dependent variable in which there corresponds exactly one value of the independent variable. It's as simple as that. One value of the dependent variable is one value. Type of function is the minute-to-one function. So let's read on the board, then I explain. If the codomain of the function has at least one element, which is the image, for two or more elements of the codomain, then the function is said to be minute-to-one. So if at least we have one element of the codomain that is related to two or more of the domain. So the domain in this case I've explained before is the independent variable, and the codomain, which is the range, the values is the range, is called the dependent variable. So if this dependent variable could have more than two of the independent variable, then the function is said to be many-to-one function. That is, the many is that the independent variable gave us two outputs when we put in one input of the dependent variable. So we are going to be taking one example so that we can understand the many-to-one. Then we will map it from the example that is given. Let us dive in. The example that we will use to check if this function is a many-to-one function. For the problem, consider the function f of x equals to x squared, where x is 2 and minus 2 is f of x many-to-one. It's a question that is asked. So we are going to be solving it. When we are done solving it, we would. Okay, so from the problem now, we write solution. Solving our problem, you can choose to write whatever you care here, but I just decided to use this shorthand. Okay, so now we are having f of x as equals to s squared. So when x is equal to 2, f of x will be equal to 2 raised to the power of 2, which is equal to 4. So when x is equal to minus 2, so f of x will be equal to minus 2 all square, which is equal to 4. So the question is this function many to 1? Yes, it is many to 1. Why? Because to each value that we put in, we have the same output. So how do we plot it out on the function mapping? So we have this and we have this. So here is A, here is B. A is considered to be the domain, and here is considered to be the codomain. So here we are going to be having 2 minus 2. We are going to be having 4 and let's say 5. Okay. So we now see that here comes here, here comes here. So here we have the many to 1 function. Many to 1 function. I believe here is very, very explanatory. So you can put in more examples of yourself and give yourself more examples and then practice it on the mapping and know how you can interchange it from mapping to the main equation. And you see that it will make more sense. So it's subjective function. Let's dive in. So a function f so that A goes to B is called an onto function if each element of the codomain is involved in the function. If each element of the codomain is involved in the function, an onto function is also called a subjective function. Now, in this onto function, it's more or less like the one-to-one function, such a way that to each element of the codomain, there's one element of the domain. So let's just take one example that we could understand, and from there we understand more of this. Okay, so here we have f of x is equal to x squared. Okay, let's find it when x is equal to, let's say, 2, 3, and 4. So when x is equal to 2, f of x is equal to 4. Because when you square 2, when x is equal to 3, f of x is equal to 9. When x is equal to 4, f of x is equal to 16. So now you can now map this and this, and you will get the exact mapping of this onto function. Type of function that we'll be discussing is just the bijective function. The bijective function is more or less a one-to-one function in the sense that the same laboratory and the same examples that we gave in the one-to-one function is more applicable to the bijective function. So the basic thing you need to understand is to understand what is the many-to-one function and the one-to-one function. The rest fall into those two categories because to each element of the codomain or the domain rather, that is the independent function, you either have one or two of the independent function, and it both apply to either many-to-one or one-to-one. So the subjective and the bijective function fall in between those two. So do it to go back, you can replay the video back, and then you have more understanding of what types of functions are. So we are going to be diving into two examples, and then I will drop a kind of work for you and give maybe kind of few minutes to solve it. Then we enter into the last phase of this class of today. Okay, let us go in already. Find the value of the function f of x, which is equal to 2x minus 4x plus 1, where x is minus 1, 0, and 2. Is f a one-to-one function? All right, let's dive in. So we are going to be solving it very, very systematically so that you understand it clearly. So we have f of x, which is equal to 2x squared minus 4x plus 1. Okay, so when x is minus 1, so f of x is equal to 2 into minus 1 squared minus 4 into minus 1 plus 1. And if you play with this very, very well, we're going to be having here 2 plus 5, because minus and minus will give us plus. So 4. 4 times 1 is 4, and then plus 1, and then you're going to be having 7. So the second one, when x is equal to 0, f of x will be equal to 2 into 0 minus 4 into 0 plus 1. And we are going to be having is equal to 1. So here is 0 minus 0 plus 1 is equal to 1. And then finally, we have that when x is equal to 2, so we will have here f of x, which is equal to 2 plus 1. And then we continue solving it from this other end. And when we play with that, what we are going to have is that we're going to be having 2 times 4 minus 8 plus 1, which is equal to 8 minus 8 plus 1. We're going to be having 1. So at the end of the day, we have range of values as okay, let's just map it out so that we know what we are solving now. Here is B. So we have f of x, or f the function at the middle here. So we have here when s is minus 1, 0, 2. What we got here in the first case was 7. What we got here was 1, and we still got 1. So if we are to map this, we will say that this is entirely not a 1-to-1 function. It's not a 1-to-1 function. Why? Because when this was this, what this give us is this was here and here was here. So it's a one-to-many function. So the answer is no. Why? Because for one value of this, it gave us the same value for 0 and 2. I believe it's well explained. So here is the example of how you are going to be finding it in your subsequent exams or questions when you are given. In composite functions, when you talk about composite functions, it's a combination of 2 functions together. You know, all the examples have been given previously is just a particular function. So in a situation where you have 2 functions, how do we work with it? How do we solve such problems? Let's say you are given a function f of x, you are given that function g of x, and you are asked to find the sum, the quotient, the difference of those functions. How do you work on them? So we're going to be giving an example, or sorry, before the examples, we'll give the rules of engagement on such problems. You know, in each concept in math, there are always rules to follow in solving them, so that you don't use what you believe is true to solving them and getting them all wrong. So let us go into the rules of composite function. But before then, a function given by f of f dot g, that is the product of 2 functions, both being a function of x, is equal to f into g of x, is the composite of f with g. That is the combination of f and g function. Here we are telling us that the product of 2 functions, f and g, all being the function of x, is a composite of those functions, f and g. The domain of f dot g, that's fg, is the set of all x in the domain of g, such that f of x is the domain of f. So the functions can be combined in various ways to create new functions. So all what composite functions is talking about is how we could deal with 2 or more functions added together so we can be able to solve them. Okay, so let's look at some rules of composite functions. Then after that, we'll go and look at some few examples. Then we look at inverse. The first one is the sum. So given 2 functions, f of x and g of x, say let f of x be 2x minus 3 and g of x be x squared plus 1. If you are to add 2 functions together, what you have to do is to check adding them by its powers. So from here we know that the first function does not have any with power or with a greater square outside this. So we took this one first, and then this one you check which of them here have the same. No, so we took this one here, and this of course and this are together. So minus 2 plus 1 is minus 2, and you get them like this. So what we are telling us in sum in composite functions is that when you are given 2 functions, you add them according to their powers. According to their powers. If they are all of the same powers or of the same degree rather, you don't add them, because you can only multiply them to a different degree. But when you are adding or subtracting, you add them according to your degree. So the first one has degree 2. You check here, does it have degree 2? No, you take that one down because it's of the highest degree. You check the next question, which of them have the greater degree? After 2 is 2x. And then the next one is a constant. So you go on and then work on it. The same thing is applicable on the different sides. You check which of them have a higher degree. You either add them or subtract them. So from the product rule, very, very simple. You can see something very, very good here. In the product rule, you multiply them directly. What that means is that this times this, multiplied by this times this, and this times this, multiplied by this times this. So you can 2x times x squared is 2x cubed. 2x multiplied by 1, okay, 3x, so multiply by x squared is 3x squared. 2x multiplied by 1 is 2x. Minus 3 multiplied by 1 is minus 3. It's very, very simple. That's why I work with the product. You take what is here and go to this other side and put it in. You get your solution. And that's it. And for the quotient rule, you just divide them according to their degrees. If they don't have the same degree, you let them be the same way they are. That's why we have this. So we are going to be applying these rules in solving how many questions? Let's say maybe 1 or 2 questions. And then we'll now give a little classwork before we progress. So let us go in and solve those problems. So we are considering one example in composite function. Given f of x is equal to 2x minus 4 and g of x equal to x squared plus 3. The question says find f into g of x and v say find g into f of x. So what do we do here? We apply the rule, the sum rule in composite functions. So what we are going to be doing is to write here, they say g into, so write 2, okay, f into g of x, rather, which now we are going to be having 2, anywhere you see x here, f of x, you put this, that's what it means, into this. So we're going to be having 2x squared plus 3 minus 4, okay? This f into g of x, it means that anywhere there is x, you should put in this, whatever you have here. So that's what we did here. So we now solve, we now have that, you know, we're going to be having 2x squared plus 6 minus 4. You now work this, you're going to be having 2x squared plus 2. Very simple. Very simple, as simple as that. So this is A, this of B. We have to find G into f of x, which is equal to, we write this. So instead of us writing s squared, we're going to put this into x. So we're going to be having 2x squared, 2x minus 4, all into squared plus 3. So what we are going to be having now is to find the square of this. So we are going to be having 4x, 4x squared minus 6x minus 8x okay, let me clean it so that we'll write it over this other side. So minus 16x plus 16 plus 1. Okay, that's when you finish solving everything. Now this is what you're going to be having. So when you now work this through, we're going to be having, let me draw the line here.